Hey there. All right, today we are going to do lesson 21 problem set. And it's asking us to use a centimeter grid paper, which you probably have in your workbooks. But I am going to just go ahead and continue working with the T-chart strategy and kind of doing more of an algorithm based focus for this problem set. If you want to play around with the grid, you absolutely can. But let's just continue moving forward from kind of where we left off yesterday. So what they're asking us to do is to shade and label as many rectangles as we can with a perimeter of 16 centimeters. So in this situation, we're trying to find the perimeter and not the area. So when we go to set up our T-chart, remember, we are going to identify the perimeter that we are trying to solve for, but to simplify our calculations, we're going to divide that by 2 so that we only have to find 2 of the 4 side lengths. Since we know it's a rectangle, we know that the length will be identical on the other side and the width will be identical on the opposing side. So we can really just figure out 2. So we're going to cut that rectangle in half, kind of creating a triangle, and calculate those side lengths. So if I divide 16 by 2, I end up with 8 centimeters. And since we're using perimeter as our kind of starting point, we're going to be adding up the side lengths to 8, not multiplying. So a 1 by 7 equals 8, a 2 by 6, a 3 plus 5, and a 4 plus a 4. And once I hit that double, I know I'm finished because it's a double. And the next one would be a 5, which would be a flip. So we're going to sketch these rectangles and label the side lengths. So you're going to want to kind of think about your sizing and your placement so that you can fit them all, because we have 4 to fit in here. And then a 2 by 6, right? That would come down a little farther, not go quite as long. There's a 6 and a 6 and a 2. And then a 3 by 5 is going to come down even farther and get a little shorter on the length. Here's my 3 by 5. And then my 4 by 4 is going to be a what? Yep, a square. So my 4 by 4 I will put here. All right, so I have done everything they asked for. Sketched the rectangles and labeled all the side lengths. B says to find the area of each rectangle you drew above. Now, if you think back to our unit on area is the inside of the figure. And so we were actually putting calculations inside those figures. And we're going to go ahead and do that here. They didn't give us a ton of space, but we have enough room in our figures. If you want to write them down below, you absolutely can. But I want you to write down the formula just as a reminder, right? We are doing length times width. Area equals length times width. So my area is going to be 3 times 5. Area equals 15 centimeters squared. There's area 1. Well, really 3. I'm working backwards for some reason. The second rectangle is a 2 by 6, right? So this area is 12 centimeters squared. Up here, I have an area that is a 1 by 7. So my area equals 7 centimeters squared. Don't forget, these ones are working in square units. These perimeters are not, because they're simply a line and not a tiling occurring in the middle. Here I have an area or a figure with the dimensions of a 4 by 4. So my area is 16 centimeters squared. All right, so I have completed the requirements for B. Number 2 says, on your centimeter grid paper, shade and label as many rectangles as you can with a perimeter of 18. Sketch the rectangles below, label the side lengths, find the area. All right, so we're going to do the exact same process here, but we're going to do it with a perimeter of 18. So if my perimeter equals 18 centimeters, remember, a rectangle has 4 sides and has 2 sets of congruent sides. So we're going to cut that in half and only find a length and a width. But since we're cutting it in half, we have to cut our perimeter in half by dividing it by 2, which gives us side lengths that need to add up to 9. So 1 plus 8 equals 9. 2 plus 7 equals 9. 3 plus 6 equals 9. Do you see the pattern? We're like counting up and counting backwards. 4 plus 5 equals 9. And then I would hit 5 plus 4, which is my flip. So I'm finished. So I have 4 rectangles to draw here as well. So I'm going to start off with my 1 by 8. There's 1 by 8. I have a 2 by 7. You can kind of find a rhythm as you go through these, huh? You can use one sizing to adjust your next size. And then I have a 3 by 6. You know me, I like organization. All right, and then I have a 4 by 5, which isn't quite going to be a square, but it's pretty close. All right, so I have met the requirements of the questions. Everything's labeled, everything's generated. Find the area of each rectangle you drew above. Area, remind yourself each time, is length times width. So I'm going to go ahead and I'm going to solve up here in the rectangles themselves so that we can see which areas go with which figures that we've created. Area of figure 1 is a 1 by 8. So that area equals 8 centimeters squared. Area 2 is a 2 by 7. So that area will equal 14 centimeters squared. Got to keep your work neat if you're going to do it this way for sure. Area here is a 3 by 6. So that area is 18 centimeters. And we're getting larger in our areas here. And then here I have a 4 by 5. Which equals 20 centimeters squared. All right, so we've done all of the above. So I want you to kind of think about that a little bit though. Like our long skinny figures, okay, have a smaller area than our figures that are more square. And that will be something that we will find will hold kind of as a mathematical pattern for us as we explore perimeter and area. Alrighty, on the back it says, use centimeter grid paper to shade in as many rectangles as you can with the given perimeters. Use the charts below to show how many rectangles. Okay, so we're basically doing the exact same work, but with different perimeters here. So let's see, we're working with 10, right? So we can kind of use this. We're going to divide this by 2. And we can see they're already going that direction. 1 plus 4, right, equals 5, which is what we have discovered we are trying to find. Now they're just throwing in the area. So you got to be a little careful here. Let's go ahead and build all of our rectangles first, and then we can go ahead and put the area in there. I want to caution you because here we're adding side lengths and here we've multiplied them. So just really don't work too fast when you're solving these ones. So a 1 plus a 4 equals a 5. A 2 plus a 3 equals 5. And then a 3 plus a 2, that's the flip, equals 5. So instead of just putting the area here, I would suggest you then write the math problem just so you don't accidentally do multiplication here or addition here. So we've made 2 rectangles for a perimeter of 10. For a perimeter of 20, again, don't forget. Okay, so this is a common thing that happens is people will just start adding up sides, or they'll forget and they'll start multiplying sides up to this perimeter because they've kind of lost sight of what they're trying to solve. You have to cut this in half. Okay, always when you're working with generating rectangles with the same perimeter. So we have 20 divided by 2, which equals 10. So they've given us the 1 by 9. Adding, right? 2 plus what equals 10? 2 plus 8. 3 plus 7 equals 10. 4 plus 6 equals 10. And 5 plus 5. And since we've hit a double, we know we can stop. Now here, we're multiplying because it's area. 2 times 8 equals 16 centimeters squared. Put that square there, or the word, because this is area and that unit of measurement shifts, right? 3 times 7 equals 21 centimeters squared. 4 times 6 equals 24 centimeters squared. And 5 times 5 equals 25 centimeters squared. Okay, and again, we can see this, right? The longer and skinnier it is, the smaller the area, the more square it becomes, the larger the area is produced. Did you make a square with either of the given perimeters? Yes, right here. How do we know? Because squares have side lengths that are all the same, and we've got 2 5s, which means we truly have 4 5s. So, yes. Okay. One rectangle is 5 by 5, which makes it a square because all 4 sides are the same length. Right? Okay. Macy and Gavin both draw rectangles with perimeters of 16 centimeters. Use words and pictures to explain how it is possible for Macy and Gavin's rectangles to have the same perimeters but different areas. So have we already done a 16 perimeter? We did on the top. Okay, so on the front page, we have 4 rectangles we could choose from for this example to support our thinking. So why don't we do a 1 by, let's do like the total opposite ends of the spectrum. Let's do the 1 by 7 and the 4 by 4. So let's say Macy draws, okay, so let's put Macy here, right? Because it's nice to pick extremes when you're showing an answer like this. So Macy does a 1 by 7. Okay. And she has a 1 plus a 7 plus a 1 plus a 7, right? Equals an 8 plus an 8, which gives us a perimeter of 16. But her area, right, is 1 times 7 equals 7 centimeters squared. Now we have to show that Gavin has the same perimeter, but a totally different area. So Gavin, we said, was going to do a 4 by 4. So if he's doing a 4 by 4, right, he's going to have a square. 4, 4, 4, 4, which gives us, right, a perimeter equation that looks like that, which is an 8 plus an 8, which gives him a perimeter of 16 centimeters, just like Macy, but his area is a 4 times a 4, which equals 16 centimeters squared. So Gavin's area is much larger than Macy's. Use pictures and words to explain how it is possible. Okay, so Gavin and Macy both have perimeters of 16 centimeters, but Gavin's area is much larger. Okay, and here we have all the math and the models to support our thinking. Now, with lesson 21, there is this data sheet that goes with it. And this is going to kind of build into lesson 22, which focuses more on line plots. So what we're going to do is we're going to save this data sheet for tomorrow's lesson. We'll fill it in and then we'll work on the line plots from there. All right. Good luck with the work today. I know you guys are going to nail it. If you have any questions, save them for our Zoom chat or send me a message on Seesaw. All righty. Bye.